Hey guys, welcome to the machine learning tutorial series. In this episode, we're going to look at conditional probability and Bayes' theorem. Many machine learning techniques and statistical models implement Bayes' theorem to perform predictive analytics to give the probability of an event occurring. For example, finding the probability that a patient would get heart attack or not, or finding the probability that the share price would go up or down. In this tutorial, we'll look into the basics of conditional probability and Bayes' theorem, and in the next tutorial, we will see how these are implemented by statistical models to perform predictive analytics. Assume that there's a football field and the field is non-playable many days a month because it is wet. The field becomes wet because of two reasons. One is rain and other is sprinklers, which is turned on the previous day for court maintenance. It has been observed that on an average of 30 days a month, 7 days the field is non-playable, about 15 days a month it rains, and about 10 days a month the sprinklers are turned on. It's also been observed that about 4 days a month the field is wet and it has rained the previous day, and also 3 days a month the field is wet and the sprinklers were turned on the previous day for court maintenance. So now you should observe that, even though it rained 15 days a month, only 4 days a month the field is wet because of rain, and only 3 days a month the field is wet because of the sprinklers. So these are represented in terms of probability. So probability of the field being wet on any given day is 7/30. Probability that it has rained the previous day is 15/30. Probability that the sprinklers are turned on any given day is 10/30. Probability that the field is wet and it has rained the previous day is 4/30. Probability that the field is wet and the sprinklers are turned on any particular day is 3/30. Now let us view this situation in the form of a Venn diagram. So this green portion over here represents the represents the probability that the field is wet, which is 7/30. The blue region represents the probability that it has rained the previous day, which is 15/30. The red region represents the probability that the sprinklers are turned on, which is 10/30. There is a small region which intersects. So this intersection region represents the event of field being wet and the event of rain. So which is 4/30, which we already saw. And this intersection region over here represents the event of field being wet and sprinklers being turned on, which is 3/30. For the sake of simplicity, let's not consider this sprinkler and just consider the rain and wet field for now. So now we are given with a scenario. Given that it has rained the previous day, what is the probability that the field is wet? So now we are given the fact that it has rained the previous day. So this event has already occurred, which is the rain. It has already rained. So this entire event has already occurred. What we need to find is the probability that the field is wet. Now, given the fact that it has rained, we don't know if it is this region or it is this region. So this region above this intersection represents the event of raining but the field not being wet, and the intersection region represents the event of raining but the field being wet. But we need to find the probability of the field being wet. So what we need to find is the fraction of this region with respect to the whole event of rain. Okay, so the probability of wet field given rain. So this is how we represent the question: probability of wet field. This standing line stands for given rain. So probability of wet field given rain. Whatever parameter is given after this line is the event which has already occurred. So the event of rain has already occurred, and what we need to find is the probability of wet field. Okay, so probability of wet field given that it has already rained. Okay, so it has already rained. We want to know if the field is wet because of the rain. So which is the fraction of this region with respect to the whole region, which is given over here. So probability of wet field and rain divided by probability of rain. So probability of wet field and rain is 4 by 30 divided by probability of rain, which is 15 by 30. So the probability of wet field given rain is 4 by 15. You should observe that probability of wet field given rain is different from just the probability of field being wet, which is 7 by 30. This is called conditional probability because we are finding the probability of one event, which is wet field over here, conditioned on the occurrence of another event, which is rain over here. Let's look into another scenario. So this time, given that the field is wet, what is the probability that it has rained the previous day? So we know that we are given the fact that the field is already wet. So this entire event has already occurred. But we don't know but we don't know because of what the field is wet. We don't know if it is because of rain, which is this event, or if it is because of sprinkler, which is this event. So what we need to find is the probability of rain, given that the field is already wet. So we know that the field is already wet, but we don't know if it is because of rain or if it is because of the sprinkler. So we want to find the probability of rain alone, given that the field is already wet. So we use the same logic. We have to find the fraction of this region, probability of rain and wet field, with respect to the whole region of which is the probability of wet field. So which is probability of wet field and rain divided by probability of wet field. If we substitute, we get 4 by 7. So the probability of rain given wet field is 4 by 7. Now let's take both these scenarios together. So I've just written it over here. Let me rearrange this equation. So after rearranging this equation, I'm just retaining probability of wet field and rain on the left hand side for both the cases, over here and over here. So for both the cases, the left hand side is the same. Okay. So since the left hand side is the same, I will equate the right hand side of the equation, and I would get an equation like this. And again, rearranging the same equation, I get something like this. So here I can get the probability of wet field given rain from the probability of rain given wet field. So this equation gives the relationship between the two conditional probabilities. Okay, the relationship between wet field given rain and rain given wet field, and vice versa. Now this equation is a simple example of the Bayes theorem. Okay, so we will use this quite predominantly in many statistical models like LDA and QDA. In the next, we will see a simple example of the application of this Bayes theorem equation. Consider this scenario for the example. We are given with this information. The probability of rain is 15 by 30, probability of sprinkler is 10 by 30, probability of wet field given rain is 4 by 7. So we know by fact that it has rained, and the probability of the field being wet because of the rain is 4 by 7, and probability of wet field given sprinkler is 3 by 10. So we know by fact that the event of sprinkler being turned on has already happened, and the field being wet because of the sprinkler is 3 by 10. So this scenario is represented in the form of a Venn diagram. So the green portion represents the probability of field being wet, which we don't know. The blue portion represents the probability of rain, which is 15 by 30. The red portion represents the probability of sprinklers being turned on, which is 10 by 30. The intersection region represents the probability of the field being wet and rain, which we don't know from the given. And the intersection portion over here represents the probability that the field is wet and the sprinklers being turned on. We don't know this as well from the given. What we are required to find is the probability of sprinkler given wet field. So we are given the fact that the field is already wet, and we want to know the probability that the sprinkler is turned on, given the fact that the field is already wet. Okay, so from the simple Bayes theorem, we can write probability of sprinkler given wet field, which is the question, as probability of wet field given sprinkler into probability of sprinkler divided by probability of wet field. But we don't know the probability of wet field. So the probability of wet field, is the addition of these two intersections, right? So addition of probability of wet field and rain with probability of wet field and sprinklers. So probability of wet field is just the addition of these two intersections. But we don't know probability of wet field and rain or probability of wet field and sprinklers, right? So what we'll do is we'll use the simple conditional probability theory to actually expand these intersections. So probability of rain and wet field is nothing but probability of wet field given rain into probability of rain, and probability of wet field and sprinklers is nothing but probability of wet field given sprinklers into probability of sprinklers. Now we know the value of each and every parameter in the last equation, so we'll substitute this over here and we'll substitute all the values of this equation from the given, and if you substitute correctly you would get a value of 7 by 27. So the probability of sprinkler given that the field is wet is 7 by 27. So this is a simple example of Bayes theorem. In the next tutorial we will look into how Bayes theorem is used for performing predictive analytics by algorithms like LDA and QDA. Thanks for watching.